Thanks, Betsy. In this crazy and somewhat scary time we're going through, it's a comfort that the natural world continues on. Prince William Sound is in its annual explosion of life. The threshers are singing, the whales are breaching, the plants are cleaning up, and the salmon are returning. We have to remember that though many of us think of Prince William Sound as a pristine and wilderness type area, that people have lived in Prince William Sound for over 5,000 years. And in that regard, we want to appreciate and acknowledge those people that still live out there, the Chugach peoples. This symposium is organized by the Prince William Sound Stewardship Foundation. The foundation is dedicated to maintaining and enhancing the wilderness character of Western Prince William Sound. We are a community of individual and organizations supporting education, restoration, and stewardship projects that serve the Sound's ecosystem, residents and visitors. We are dedicated to keeping the Sound healthy, clean, and wild for everyone. The foundation coordinates volunteer opportunities such as beach cleanups, educational events like this symposium, and much more. We're a group of volunteers dedicated to the foundation's mission and the amazing place we call Prince William Sound. This is our second Natural History Symposium, and we hope next year to be back live and see everyone in person. Have patience with us outdoor types as we navigate the technological bushwhack of crowdcast. One of our board members, Pete Denmark, has joked that we're sort of like a cruise ship on wheels here. We all belong out in the Sound and out on our boats and on the land, and here we are in technology world. So here we are, a cruise ship on wheels, so to speak. This symposium is sponsored by the Prince William Sound Stewardship Foundation, the Prince William Sound Regional Citizen Advisory Council, with generous support from Discovery Voyages, Glacier Jet Ski Adventures, PDN Engineers, and Whittier Seafood. As we go along today, we have a great lineup of speakers. We'll go through a few about an hour at a time, and then there'll be about a 10-minute break. And all to get up, get your caffeine or whatever you need, stretch your legs, use the bathroom, get a snack. And then the Betsy and Heather Tham, who's also helping with technology, will bring us all back in to the next session. So all you have to do is hang out. If you want to leave and come back, you'll just jump right back in wherever we're at. Also, all the sessions will be recorded, and we'll eventually have them up on our website. So if you missed something or you know of someone who is interested in one, you can direct them to our website and see them again. So again, as Betsy said, if you have a question, go to the Ask a Question at the bottom of your page, and I will try to help the speakers direct them to those questions at the end. We'll have anywhere from 5 to 10 minutes at the end of each session to get those questions answered. So that's all I have for an introduction. Thank you for joining us. If in a few minutes we'll get started with the Chugach Region environmental initiatives, followed by the effects of recent marine heat waves on the waters of Prince William Sound. So hang tight, and we'll welcome in our first session.
Paul, I'm going to bring Willow and Chelsea on the screen now.
Okay, great, thanks. So while that's happening, I want to go and introduce our first speakers. They'll be talking about the Chugach Region environmental initiatives, and we welcome Willow Hendrik and Chelsea Kovalcsik. I hope I got that right. Great. Welcome, and thank you for doing this with us. Mrs. Hendricks has a BA in Marine Resource Management, an MS in Natural Resource and Environmental Management, an MPA in public administration with a focus on natural resource policy. She was born in Prince William Sound and raised in Moose Pass and takes pride in serving the region to this day. Chelsea graduated BS in Environmental Science from Chatham University in Pittsburgh, Pennsylvania. She served as an American Corps Vista with Chugach Regional Resource Commission, CRRC, for 2 years. She is very passionate about indigenous rights, environmental conservation, and youth engagement and education. So welcome, and we look forward to seeing your presentation. I'll turn it back over to you all.
Hey, good morning, everyone. Give me a moment here as I share my screen. Okay, can I get a thumbs up that people can see our presentation? All right, fantastic. Well, thank you all for being here this morning. Happy Monday. Like Paul said, my name is Willow Hendrik. I am the Executive Director of Chugach Regional Resources Commission. We abbreviate that as CIRC. So we're going to start using that. And if we use them interchangeably, I hope that doesn't confuse you all. CIRC is a nonprofit entity located in Anchorage, Alaska. We serve the 7 tribes of Prince William Sound and Lower Cook Inlet. Those are Port Graham, Nanwalek, Tutitlik, Chiniga, Valdez, Eyak, and Kovalcsik, which is located in Seward, Alaska. We're a 501c3, and we're an intertribal organization that works on fish and wildlife issues in our region. Today, Chelsea and I are co-presenting. I'm going to talk to you about a little bit of overview of tribes in Prince William Sound, talk about some traditional food initiatives that we've been working on, and then our newest program, which is wetland mapping in the region. And then Chelsea's going to talk to you about tribal water quality monitoring that occurs throughout the region and climate change and subsistence resources. But first, I wanted to read you all a note from our chairman of the board. He's also the chief of the Port Graham Village Council, Mr. Patrick Norman. Some of you may recognize him. So I'm going to look down so I don't mess anything up because he wrote a very nice welcome to all of you. As chairman of the board of Chugach Regional Resources Commission, I speak for my tribe as well as others in Prince William Sound and Lower Cook Inlet when I say that we are thrilled to have the opportunity to share a part of our culture with you today. For our communities, natural resources are a gift. Traditional foods and our traditional homelands restore physical health and are central to cultural and spiritual traditions. Healthy and productive people are the cornerstone of our healthy communities. The intrinsic value of harvesting and consuming local food in traditional ways cannot be overstated. A local statement is, when the tide is out, the table is set. Our ancestors provide a living legacy and direct connection with the lands we come from. Since our ancestors have lived in this region, the environment and primary food sources have changed dramatically. The natural environment is more than just commodities. It is our greatest gift that help us to always remember who we are and where we come from. Our lands weave together the very social fabric that make us a community. They contain the building blocks of our blood, our genetics, and when we are actively on the land pursuing wild game or fishing our sacred waters, we are gifted with new memories and those of a distant past. These memories settle us in a sense of belonging that promotes balance and generosity. Our people have great potential in shaping a region that feeds the future in a way that strengthens our relationships with all living things and promotes cultural continuity. This can be done by becoming more than just users of the land and the sea or consumers of its foods, but advocating for the preservation of our ancient way of life. This means promising to always practice good stewardship, experience reciprocity, promote collaboration, and celebrate the spirit of generosity through acknowledging the wealth of knowledge that our traditional lands offer. Koyana. So thank you, Mr. Patrick Norman. He couldn't be here today. I'm honored to have been able to read that very moving piece from him. Little bit of a quick overview. Chugach Regional Resources Commission is part of a slew of nonprofits that serve the Prince William Sound region. Chugachmu, they are the Human and Social Services Organization. North Pacific Rim Housing Authority is the housing authority for the region, and CERC is the Natural Resource Management. Now, these are just the nonprofits. Of course, we're going to hear from Chugach Alaska Corporation later. They are the regional for-profit corporation. So we are proud to see ourselves as a leader in tribal natural resource issues in Alaska, especially South Central. We were created in 1984, and since then have been intricately involved in research, monitoring, and restoration projects, specifically post Exxon Valdez oil spill. And since then, we have expanded, since the oil spill, we have expanded our programs to include subsistence harvest, migratory birds, shellfish, which you'll hear about a little bit later from Chelsea, ocean acidification, and natural resources. I mentioned that we had 7 tribes that we serve. 4 of those are located in Prince William Sound, and I just wanted to take a moment to read you some statistics from all of these tribes. First, we have Valdez, top left. The Valdez Native Tribe is located in Valdez, Alaska, and most of you know that's about 300 miles from Anchorage. For the Alaska Native people in this region, Valdez was historically a favorite place to hunt, fish, gather, and trade, and it still is to this day. The Valdez Native Tribe was formed in 1974. They're a 501c3 nonprofit, and they provide the local Native community with culturally relevant health, social, and educational services in the Valdez area. Currently, there are over 750 individuals and 190 households who are registered with Valdez Native Tribe. Their mission is to promote the unity, self-determination, and empowerment of the Alaska Native and American Indian beneficiaries in the Valdez area. Next, I'll go clockwise over to Chiniga. The people of the Chiniga tribe have lived in Prince William Sound for over 10,000 years, fishing waters and harvesting the abundance off their land. They are part of the Aluktik tribal family. The native language for the Chiniga people is called Sukstin, and the word Chiniga actually means beneath the mountain. Until the 1964 earthquake, Old Chiniga, which is not New Chiniga now, was a fishing village on the actual southern end of Chiniga Island in Prince William Sound. It was the longest occupied village prior to the earthquake. Of course, the earthquake changed many things, and actually the village of Chiniga experienced a devastating tsunami. The loss of life was catastrophic. In one single event, centuries of history were washed away. 26 of the Chiniga people, which was 1/3 of their village at that time, lost their lives. Chiniga suffered the highest percentage of loss of life of any community in the earthquake. With the village gone, the Chiniga people were relocated to where they are now, which is in Sawmill Bay. And then, of course, came Prince William, the Exxon Valdez oil spill, which was equally devastating. Chiniga, of course, is only accessible by air and by water when the Alaska Marine Ferry is running, or if you have a private boat. Next, we'll go to Tutitlik. There are about 100 people that live in the native village of Tutitlik. It's located on the northeast shore of the Tutitlik Narrows. I mean, how beautiful is that aerial photo? I just want to be there today. And the subsistence lifestyle is still a very important part of Tutitlik's culture and economy. And of course, as I've spoke before about the other tribes, in 1989, when the Exxon Valdez oil spill ran aground, it was actually not far from Tutitlik. And it carried crude oil everywhere and also towards the waters and the land in Tutitlik. Tutitlik lives a very strong culture and subsistence lifestyle to this day. And then, Eyak is the tribe that's in Eyak is actually called the Native Village of Eyak. They're federally recognized. There's 515 enrolled members in the tribe. And of course, Cordova is a very large fishing community. It's located on the eastern Gulf of Alaska. I'll split back here. Between the major between the major ecosystems of Prince William Sound and the Copper River Delta. The Eyak territory is the traditional meeting place of the four peoples, the Eyak, the Aleut, the Tlingit, and the Athabaskan. And the Prince William Sound, the Copper River Delta, and the northern Gulf Coast of Alaska were all shared between those four peoples. Today, Eyak is governed by a 5-member elected council, and they promote self-determination to Native Village of Eyak tribal members. One thing I just want to honor this morning is COVID-19 and all of the hardships that our tribes are facing as businesses start to open up and the summer season starts to kick off, especially the fishing season. Please be respectful that these communities do not have the large support, the healthcare support system that we have in Anchorage. And as far as I know, as of last Thursday, both Tititlik and Chuniga are off limits for visitors at this time. That includes stopping at the dock to take a break, and it includes stopping at the dock to get fuel. Well, one of the initiatives that CERC has been working on lately is the traditional foods assessment, because they restore physical health and are central to the people's spiritual traditions. Here are some stats on the slide from a food survey that we had conducted throughout the region. We did 3 things during this food assessment. One was to get these great statistics about how people use traditional foods and why they are so important to them. The second thing we did, which you'll see a little later, is a poster of all the important traditional foods. And then we also created a recipe book, and I'm going to share with you some of those recipes today. From our traditional foods assessment, we were able to determine during what season resources were used in the highest abundance. You can see from this word cloud that in winter, tribal members rely heavily on king salmon, bidarkies, sea ducks, and cod. In the spring, tribal members rely heavily on seaweeds, fireweeds, fiddleheads, octopus, black bear, and seals. In the summer, tribal members rely heavily on a lot of resources. Of course, salmon is the highest one, and then our beloved berries. In the fall, tribal members rely heavily also on berries, mushrooms, bear, and moose. Along with Sarah Glasser, who is also from Moose Pass and went to Seward High School, CERC created this traditional foods poster. It's a depiction of all of the top 10 of the animals that are harvested in the spring, the summer, and the fall, and the winter. And this has really been one of our keystone creations. People love this. We love it. We use it for everything. And we do have some available if anyone is interested. This was translated into Sukston. However, I forgot to mention that actually all of our 7 tribes have a different dialect. It's amazing. Even to be so close like Chuniga and Tititlik, you'd think that they would speak the same language, but no, that's not true. This translation was done from the native village of Nanwalek, and we have been working towards getting it transcribed into each of the 7 dialects, which is not an easy feat. It's been quite the program. I also talked about a recipe book that we made. When we did the traditional foods assessment, we really, really wanted people to give us their recipes because we thought it would just be the greatest connection between those 2 initiatives. I thought I'd share some with you. I'll leave them up on the screen for just a second. And of course, you'll have this PowerPoint a little later. So Chuniga halibut tacos. This actually came from the Chuniga Bay School. And then we're going to have a question for you here pretty quick. Barbecue bear black ribs. This came from Wally Kvasnikoff. And the question is, and Betsy's going to spin up a poll, how many of you listening today have had eaten black bear?
And I'll just, in case people don't see it down below where it says ask a question, it now also says poll. You can click into that to find Willow's poll and provide your answer.
Yeah, and while we're polling, some of the other meat recipes that we had were beaver pot roast, caribou hand ties, egg rolls with ground goat, goat burgers, pot roast goat, fried sea lion, seal with rice, and stuffed seal lung. Now, Betsy, I can't see when the poll's done, so you're going to have to fill me in.
Well, votes are still coming in, but right
Okay.
now we have 16 votes. Oh, it just dropped. Yeah, 16 votes for yes and 13 votes for no. But votes are still coming in, but it actually seems to be about 50-50.
Well, I encourage all of you who have not had black bear before to go and get some. In fact, my brother got a black bear last night, and I'm really excited to get a hold of it and process it. We make breakfast sausage out of it, and that's our favorite thing to eat in the springtime. So I'm very thankful for that animal. I'll keep going as the poll keeps going because I know we're going to run out of time here. One of the plant recipes that we have is oven roasted kelp chips. And how great is kelp? All right, I'm going to get quickly into wetland mapping before I turn it over to Chelsea. This is one of our newer initiatives. We just received a grant from the Environmental Protection Agency to conduct mapping in the wetland mapping in the region. Our board of directors has chosen this red boundary to do an assessment. And why wetlands, and how does that have a connection? Well, wetlands are one of the most important ecosystems for the natural world. They support lots of wildlife, particularly migratory birds, but also they're important for humans for subsistence. Most of you might not know that, well, this is obviously a wetland, but there are wetlands everywhere. And they're really, really important. And so one of the most pressing issues that we've determined is actually wetland loss. Wetland loss in Alaska in particular, this is probably no surprise to you, but in the Anchorage Bowl, over 50% of the wetlands are gone. In Juneau, 1/3 of the wetlands are lost. Now, those are big cities, of course, but as people start to expand and as development starts to expand, we need to be sure that we know where these wetlands are and that we know how to preserve them. So these coastal wetlands, they're extremely productive. They are crucial for habitat for migratory birds and fish, and they occur all over the place. Freshwater marshes, riparian. They provide nutritious foods. They provide ice formation and ice cover. They protect our tribes from breakup, and they also protect us from storm surges. And of course, as Paul mentioned, there's where the songbirds like to be, and they're like the thrushes that he said are coming to nest in the trees that are supported by wetland ecosystems. All right, I'm going to turn it over to Chelsea, and I'm running Chelsea's screen here, so forgive me if I get a little tripped up, but we'll get through this together.
Awesome. Well, can you hear me?
Yes.
Perfect. All right. Well, hi, everyone. My name is Chelsea Kovalcsik, and I am the Regional Environmental Coordinator for Chugach Regional Resources Commission and the Alutiiq Pride Shellfish Hatchery. I first want to thank the Prince William Sound Stewardship Foundation for inviting us to present. I'm super excited for this opportunity to share some of the work we're doing here in South Central Alaska. I'll be speaking to you all today on our water quality sampling program and our hunting, fishing, and gathering task force. Next slide. So I'm also going to have a poll, and I just am curious, how often do you all personally eat wild foods? Is it almost daily, multiple times a week, a few times a month, a few times a year, or never? And we will have that poll pulled up, and so I'll give you guys a few seconds to do that. Kind of a lot of answers, but and I'm asking because, as you can tell from our work here at CERC and from what I'll be presenting on, we focus heavily on traditional foods. Understanding ways in which they'll be impacted is paramount for us to not only do our jobs effectively, but actually be able to help the Alaska Native communities that are most vulnerable to climate change. And I'll just kind of keep looking. Okay. So I'm looking at the responses a few times a month. So I actually personally fall into the C category as well. But thankfully, fishing season is here. So hopefully we'll bump that up a little bit.
Mm-hmm.
And okay. All right, we can go to the next slide.
Okay.
So I'm just going to dive right in since I don't have that much time. It's important in a changing climate to understand what implications shellfish populations, wild and even hatchery, might face, especially if you manage a shellfish hatchery. Ocean acidification refers to a reduction in the pH of the ocean over an extended period of time, caused primarily by the uptake of carbon dioxide from the atmosphere. It's a little opposite of what we think, but when something becomes more acidic, it actually means the pH is lowering, not increasing. So when I talk about oceans becoming more acidic, I don't mean if you enter the ocean, your skin will burn. In fact, you wouldn't be able to feel the change at all. We can, however, think of it very simply as there is an increase in anthropogenic carbon dioxide entering the atmosphere. The ocean, which acts as a carbon sink, sequesters a bunch of that extra carbon dioxide from the atmosphere. So now there's more CO2 in the atmosphere and the oceans. A few chemical reactions happen, as you can kind of see here, and eventually the pH of the water goes down. Next slide. So how does a decrease in pH impact shellfish? Well, great question. It causes a dissolution or breakdown of their shells, which is shown here from 1, 2, 3, and 4. Shellfish, like all animals, have an energy budget. So in a perfect world, they're expending the right amount of energy on shell growth and maintenance, getting food, fighting off disease, reproduction. However, in many areas of the oceans today, shellfish are expending more of their energy to fix or maintain their shells. And this is leading to less energy to perform other necessary tasks. So OA is directly impacting their energy budgeting. Ocean acidification also affects different shellfish differently in different stages of their lives, making this a more complicated issue to study, understand, and even predict for future oceanic conditions. OA has been linked to a decline in shellfish populations, particularly in the Pacific Northwest. And a decline in shellfish populations threatens food security for Alaskans and people all around the world. Next slide. In response to other shellfish hatcheries in the Pacific Northwest experiencing mass die-offs in shellfish populations, the Alutiiq Pride Shellfish Hatchery got involved in a coast-wide hatchery sampling program, which was the start of our Ocean Acidification and Shellfish Research Laboratory, which is a tongue twister. You can see in the bottom photo the locations of places we sample in Prince William Sound. And as Willow had mentioned, it's Valdez, Titlik, Eyak, and Chiniga. Next slide. The Berkelator, invented by Burke Hales of Oregon State University, allows the Alutiiq Pride Shellfish Hatchery to quickly and accurately continuously monitor multiple ocean parameters, such as water temperature, pH, dissolved oxygen, salinity, and others, and distribute that data in real time through data portals, test discrete samples, and measure water chemistry for future dosing, which I'll talk about a little bit later. On the right is a picture of the Berkelator and a few pieces of equipment needed to keep it up and running. Next slide. These are the websites for the data portals I previously mentioned. The Berkelator takes in ambient seawater from Resurrection Bay and provides real-time data of those ocean parameters. Meaning at any time, you can go onto one of these websites when the Berkelator is on and running and see what the water quality is in Resurrection Bay. And this is a screenshot of what that will look like. And the URLs, I spaced them out a little bit so you can see them instead of them kind of being scrunched up. And these data portals and this real-time water quality sampling is important for a bunch of reasons, but two are that it contributes to a long-term data set of water quality in Resurrection Bay, and it allows us to monitor the water that we're using for the hatchery. Climate change is affecting water quality, and that will directly impact shellfish and other hatcheries. If we know the quality of the water we're using for our hatchery, then we can plan on how to adapt to it. The Berkelator has been a very powerful tool for us. Next slide. In 2015, CERC was awarded a grant from the BIA, the Bureau of Indian Affairs, for a project to monitor OA near coastal villages and communities in South Central Alaska. To do this, we train people to collect nearshore water samples within their communities. They sample once a week, same time and same place, and send those samples to the hatchery for testing using our percolator. Just like the percolator can test water right outside the hatchery, it can also test discrete samples from communities. We send participating communities a kit that contains everything they need for sampling. And we're extra proud of this project because it's an effective way to bolster community involvement. It integrates nearshore and offshore water quality data. And lastly, it fills potentially important data gaps. With climate change knocking on our front door, it is more important than ever that we create these long-term data sets by sampling and understanding what our oceans look like now versus what they did in the past, so we can hope to predict how they will change in the future. And this is a map of the sites that we're sampling at around the state. You can see the gaggle of sampling locations in South Central, but you'll also notice that we have expanded our sampling locations around Western and Southeastern Alaska. Next slide. So with all of this concern about ocean acidification, what can the hatchery do to adapt? Well, one of our solutions is to dose the tanks that hold the water for our shellfish with soda ash. Soda ash is a white, water-soluble salt, and it gives moderately alkaline solutions in water, meaning it raises the pH back up to a more comfortable level for shellfish. This obviously isn't a solution for the whole ocean, but it allows us to effectively address OA within our hatchery operations, saving us time, money, and resources. Next slide. So why is all of this important? Like, what is the kind of big question that we're talking about here? Well, and for pretty obvious reasons, really. Those are that climate change is directly connected to access and availability of traditional foods for people in our region. Rural communities around Alaska do not always have immediate access to grocery stores, meaning they rely heavily on their subsistence foods. Subsistence foods are not only nutritionally beneficial for these communities, but they intimately connect Alaska Native communities with their culture, their land, and their people. A change in access or availability of these foods can have devastating impacts on Native communities, their physical health, cultural, and spiritual traditions. I've included a quote by the chief of Port Graham, Patrick Norman, on just how important traditional foods are to him and his community. And for time, I won't read the quote. Next slide. And so with that, I would like to move into talking about understanding the regulatory process. The cause of changing resources and, in some cases, decline of food sources is not known, but it is most likely a combination of overharvest, predation, inconsistent recruitment, and environmental changes due to elevated seawater temperature, high energy storms, and ocean acidification. The lack of traditional foods in the diet of local residents has several negative impacts. Our communities lack access to healthy foods, such as fresh fruits and vegetables, and the nutritional value of traditional foods is hard to replicate with a substitute store-bought food. There is also a heightened concern about contaminants in the subsistence food that our tribal members eat. There is a lingering concern over the effect of the remnants of the Exxon Valdez oil spill and nearby gas and oil exploration, as well as increased boat traffic from tourism, fishing, and cargo transport. In addition, there has been major warming in Pacific waters where ambient ocean temperatures are several degrees higher than ever recorded. The above impacts are a perfect example of why conducting a traditional foods assessment in our region is so important. Next slide. The primary...
Kelsey, I'm just going to pop in here. You have about 5 minutes left. There are a couple questions in the Ask a Question box, so if we're able to give that a couple minutes at the end, that'd be great as well.
Sure, do what I can. The primary food sources have changed dramatically over the past 100 years. Traditional food systems such as hunting, fishing, and gathering have declined, and there has been an increased reliance on store-bought food. The intrinsic value of harvesting a local food source in traditional ways cannot be overstated. A local statement is when the tide is out, the table is set. This opportunity is currently lost. And when our tribal members lose connections to their food, they lose part of their culture, which can have negative effects on psyche. The ways in which foods are produced, distributed, and consumed have direct implications for the local economy and local community. While traditional foods may restore physical health, They also are central to cultural and spiritual traditions. And this is just a poster a colleague and I made for the Alaska Forum on the Environment. I'm going to go briefly through some of this, but if you're interested in learning more, I can always send out a PDF version. Next slide. Several Cirque tribes have expressed frustration with the federal and state management of subsistence resources, and specifically the Board of Fish and Board of Game processes. There have been several recent efforts to present proposals to the Board of Game and Board of Fish that have been rejected, either at the advisory committee level or the board level, because of the requirements in submitting a proposal. Cirque hosted a workshop which aimed to provide an introduction to the operations of the Board of Game, review proposals in Game Management Unit 15C, and learn effective methods of providing public testimony. Next slide. 3 of Cirque's 7 member tribes were in attendance at the workshop: Port Graham, Nanwalek, and Valdez. And these are just 2 of the close to 10 testimonies that were given at the Board of Game meeting. Providing public testimony is an incredibly effective way of getting your voice heard. However, it's extremely intimidating. You have to know what to say, who to say it to, how to address them, all while keeping it within the time limit allotted. During the workshop, we spent several hours working with each participant, myself included, on proper testimony techniques. Next slide. We didn't quite have the regulatory outcomes that we were hoping and advocating for. However, our main goal was, and still is, to empower tribes to become more involved with regulatory processes. This is a quote from former Board of Game member Karen Linnell. She said, "I appreciate you folks for coming up and enlightening us on your home country there. So thank you. Thank you for coming. Thank you for that." And in addition to empowering tribes, we were also able to offer this course for credit at UAA. Next slide. It's our second to last one, so we're crushing it. So COVID-19 has posed some challenges for our hunting, fishing, and gathering task force. Originally, we were scheduled to visit each of our 7 tribes and host a training in each community regarding natural resource management bodies throughout Alaska. We have shifted our focus recently and hosted an online course for credit through UIF's Tribal Management Program. The course was a total of 6 classes and spanned regulatory agencies such as Board of Game, Board of Fish, the Alaska Migratory Bird Co-Management Council, and the North Pacific Fisheries Management Council. The Board of Fish will have a meeting in Cordova in December, and if travel is safe and allowed by then, Cirque will be flying staff and participating tribal members out to Cordova to learn more about the Board of Fish and participate in the in-person meeting. We hope to continue this work past our grant requirements and find ways to expand the hunting, fishing, and gathering task force, as well as meaningful ways to advocate for tribal sovereignty regarding natural resource management. Next slide. And with that, we'd like to thank you for attending our presentation.
Yes, thank you all so much.
Yay. And open up the floor for questions.
Great. So I'm going to close your slides and bring Paul back on to help with question and answer. But we've got some great questions down in the question box. If we don't get to all of them, Willow and Chelsea, you can pull that up as we move on to Rob Campbell and maybe provide some chat answers as comments in there. That might be great. But this first question is, do you ever experience any pushback from any of the Indigenous peoples sorry, it's bouncing around on me here as new questions are coming in, for your input and insight, despite how beneficial your work is for the maintenance and improvement of their quality of life and land? That's a question from Campbell.
I can take that question. One thing I will say, I think pushback is probably the wrong term. Most of our tribes are very willing to work with us and always are engaging and helping us with grant applications and projects. One of the things that we experience as a regional organization is having little budget to serve a very large community that are very diverse. And meaning some initiatives that we might see in Chuniga are not initiatives that the Chugach Native Tribe in Seward is also experiencing. And so patience is what our board always reminds us of. Just because one community gets some funding doesn't mean that the next is not going to. They know their turn will come. And so that is one of the most challenging things for us. But our board in particular is very appreciative, and they are good tribal stewards, and they also bring our information back to the tribes to get the whole community on board.
Great. Can people hear me?
Yes.
Okay,
Yes.
great. Let's do one more question, and then we'll move on to Rob. Does ocean acidification play a role in parallelic shellfish poisoning? And do you monitor PCP at the locations you monitor water chemistry?
So to our knowledge, no, ocean acidification does not have an impact on harmful algal blooms or paralytic shellfish poisoning or any of that. And we currently CERC doesn't currently sample for harmful algal blooms or PSP. However, there are other organizations around the state that do, and we are working towards getting starting to sample at certain locations. It's a process, and it requires kind of microscopes for people to be able to look through things, and then it also requires lab space. And although we have a hatchery, that hasn't been one of our main focuses, but something that we hope to kind of move into as we move forward in time.
Yeah, and if I could just follow up on Chelsea's statement that actually today we are submitting a grant application to do paralytic shellfish poisoning and harmful algal bloom and heavy metal testing in shellfish populations throughout the Sound and Lower Cook Inlet. And then in July, we're also submitting almost an identical, very similar grant application to the Administrative of Native Americans to do that. And so we're crossing our fingers for both of those grant applications, because both of those things, heavy metals and paralytic shellfish poisoning, are some of the top issues that we hear region-wide from all of our tribes, hands down. And so we've heard the message loud and clear, and we're trying to get them funding to monitor their shellfish.
Great. Thank you very much, Willow and Chelsea, for a great presentation. We'll have your slides up on our website in the next few days. So thank you very much.
Yeah, thank you.
Next up, we are going to welcome Rob Campbell. He will be discussing the effects of recent marine heat waves on the waters of Prince William Sound. Rob is a biological oceanographer at the Prince William Sound Science Center. His current research is primarily observational and centered around trying to understand how plankton and fish interact with the physical environment, temperatures, salinity, and nutrients, to produce the patterns we see in nature. Current projects include surveys of plankton and oceanography in Prince William Sound, process studies of the seasonal evolution of the surface oceanography in Prince William Sound with an instrumented moored profiles, we'll hopefully find out more about that, and studies on the distribution of nutrients, plankton, and fish around the plume of the Copper River. It's an amazing place, and it's an amazing plume. I've paddled through there. It's an incredible place. So welcome, Rob, and I'll turn it over to you.
Great, thank you. Can everybody hear me?
We can hear you, Rob.
Super.
Yeah, we can.
Yeah, okay. I actually thought I would start off with a little demo here, because there's an interesting property of water that you all need to know about to sort of understand the oceanography around here, and that's its tendency to form layers. So I'm going to show you how that works. I have here some salt, just like the ocean has salt.
And just so you know, we can see the top of your beaker there, but not the bottom.
Right. I think my camera has a little bit too much zoom. Put a little bit of food coloring in here so you can see what's going on. There we go. Okay, so I just made some ocean water here. It's a little saltier in this jar than it is in this beaker. So I basically just added some mass. And what that does is increases the density of the water, so it makes it heavier. And so if I pour in some of this fresh water here, that heavier, denser, salty water is going to stay put. And if I'm careful and tip it over, it should all just run out on the bottom. So, so we wind up with a layer of salty water underneath a layer of fresh water. And I'll show you why that's important in a second. I'll share my screen here. There. Ah, there we go. Okay. Perfect. Can you see that? I'll assume you can.
Yes, we can.
Great. I can't see the crowdcast stuff right now. So I'm going to talk a little bit about the extraordinary heat we've seen in the North Gulf in the last little while. I'd like to acknowledge my many collaborators. This is a real group effort. So the reason I want to talk about how water tends to form layers is it really drives the surface oceanography of this region. So here's Prince William Sound up here to the left. There's that Copper River with the great big plume. And then looking down to the southeast here, you can see all this turquoise colored water. And that is, it's turquoise because it's full of glacial flour, because you can see there's lots of glaciers there. Also, you may have noticed it can rain a lot here, and all of that washes down into the ocean. And so that sets up what we call the Alaska Coastal Current, which is trapped along the coast here. And it's basically a river of fresh water on top of the more salty ocean water, just like my little beaker here. That water travels up the coast here at Kayak Island. It kind of whips around like a fire hose. It can continue along the continental shelf, or sometimes it shoots over towards Prince William Sound. We have the Copper River here, largest point source of fresh water in the North Gulf. Most of that water travels along the coast and makes its way into Prince William Sound, also setting up a layered system. And that tendency to form layers also influences the biological productivity of the ocean around here. And hopefully most people know this. Most of the ocean is above your head, so it doesn't really work for plants on the bottom. So most of the production in the ocean is done by single and multi-celled plants called phytoplankton. That's Greek for plant, plankton. Plankton means drifter. They are consumed by animal plankton, zooplankton, who are in turn consumed by smaller fish and larger fish and so on up the food web. Now, the way that this tendency of layering works is in the spring. There we go. In the spring, as the sun starts to shine more, it helps form this layer in the surface. And the phytoplankton get caught in that layer along with lots of nutrients and basically kick off and make this huge bloom. They use up all of the nutrients in the surface layer. And it's like that all summer until autumn comes around and we start getting our autumn storms. That can mix water up. We get a tiny little fall bloom before we move into the winter. Very little sunlight, very little productivity. So that's a real quick oceanography 101 of how things are working at the big scale. Now I'm in charge of the Prince William Sound component of the Gulf Watch Alaska program. That is a very large monitoring program that is funded by the Exxon Valdez Oil Spill Trustee Council. We do several surveys of the Sound every year. That's those red dots there. We also have a mooring in the Sound, which I'll talk about a little bit later. This is pretty bog standard oceanography. We go out in our boat. It's a pretty small boat, but for Prince William Sound, it works great. And we have our basic oceanographer's instrument is called a CTD, and that stands for conductivity, temperature, and depth. Conductivity, the electrical conductivity of the water tells us the salinity, how salty it is. Temperature is pretty obvious. And then it has a pressure sensor on it that tells us how deep it is in the ocean. And so we go out in our ships and you can do it. throw our CTD off the boat, and it descends through the water, measuring temperature, conductivity, various other things as it goes. And that gives us a profile of, say, in this case, I'm showing temperature. So this is also showing that tendency to form layers I mentioned. We have a warm layer at the surface, and as we move down in the water column, it gets cooler and cooler. This is the way that oceanographers often like to look at our data, with the surface at the top and depth at the bottom. Alrighty. Now, a couple of years ago, I did a exercise where I took all of the CTD data I've been collecting over the last decade or so, and as well, I went and found every other bit of CTD data ever collected by anyone else in the region and put it all together. And I found just under 25,000 individual casts of CTDs that were done, and several million data points. And when looking at data like this, there's various groups that are collecting the data. It's never collected at the same place at the same time. So I've busted it out into some different areas here, and I'll mention them a little later on. But the green is the Gulf of Alaska Shelf, the blue is the Central Sound, and the yellow is the Northwestern Sound. So diving into that, here is sort of where we have data that we can use. This is time on the left-hand axis, and just the day of year on the bottom axis. And so what we see is in the mid-70s, mid-late 70s, fairly good coverage of data. That was the time when there was a lot of outer continental shelf oil and gas research being done. Very little being done in the 80s until, of course, 1989. You might have heard there was an oil spill, which prompted quite a lot more research happening in the Sound. And then the data coverage after that is quite good. Now, dealing with a big, messy data set like this is a little tricky, and I'll show you how we do it. So here is, this is a time series, so day of year on the bottom, and of temperature on the left side here. So one person goes out 3 times of the year, they get 3 observations, great. Another group goes out, they get some more observations, maybe some at the same time, maybe some at different times. And another one perhaps goes out at different times still. So if we take everybody's data and put it all together, we start to see the seasonal pattern in temperature in the Sound. And if you're so inclined as a scientist, you can then start to model it mathematically. We're not going to go into that at all. So this is the surface temperature cycle in central Prince William Sound. This is actual data. And what we can do next is sort of step down away from the surface, deeper into the Sound. And that's what this animation ought to do. There we go. So with each step, we're going down a meter deeper, 3 feet deeper in the Sound. And you can see as we get away from the surface, the seasonal variability gets kind of damped, and it is more constant. So we can take all of that and put that together into another way to look at the annual cycle. And here I've done it with color. So the left panel is actual data, and then the right panel is smoothed out with a model, that line I showed you in the other slide. And it's kind of what you'd expect for a temperate area like this. In the winter, it's cold, everything is well mixed. And then as we move into spring and summer, we get heating at the surface layer. We start to see the temperatures increase. We get that nice layer forming at the surface. And then moving into autumn, as the autumn storms come back, that heat gets mixed down into the water column, and it becomes cool again. And we can do the same thing with salinity. And it shows pretty much the same pattern. In the winter, everything is pretty well mixed up. As we move into spring and summer, we have snow melt, we have a lot of rain, and so we start to see a layer of fresh water at the surface that, again, when we get into the autumn storms, is mixed out again into the winter. So that's great. We now have a picture of what's happening sort of on average in our corner of the Gulf of Alaska and Prince William Sound. And so that is that green line in that figure there. But of course, the departures of our data from that line are kind of interesting as well. There is a lot of variability there. That's kind of a feature of Alaska. And so what we can do is subtract our observations from our average, and that gives us what we call an anomaly. So that's the departure from average. So all of the red dots here are warmer than average, and all the blue dots are cooler than average. And that gives us a good way to look at how things are changing over time if they are above or below average. And I'll show you some of the data from those parts of the sound that I showed you earlier on the map. So this is just offshore of Prince William Sound on the Alaskan shelf. These are a time series of anomalies, so going back from mid-1974 to about 3 weeks ago when we were last out there. Each of these bars is a monthly average anomaly in temperature, and then the dots are actually the data, so you can kind of see everything with a glance. There's quite a lot of data here. The green line is the long-term trend, and I'm showing you 4 depths here. So the top panel is right near the surface, and then we move down deeper into the ocean with each successive panel. And what we see on the shelf is kind of like what we see out in the open Gulf, is a modest long-term warming trend of about 1/3 of a degree per decade. If we move into Prince William Sound, this is same format, just different data. We see the trend is not quite as pronounced. We still see lots of ups and downs, but the long-term trend is much more muted. And then if we venture even further into the sound, into the northwestern part of Prince William Sound, the trend actually reverses, and that's cooling. So it's been cooling over the last 45, 50 years in the northwestern sound. If we look at the salinity in the northwestern sound, we get a hint at what's going on. There's a negative trend. So the water is getting fresher in the northwestern part of the sound. And of course, the reason for that is because the proximity to all the glaciers and ice sheets. Here's a picture of Columbia Glacier, which is not too far from Valdez, taken in 1987. And here it is 15 years later. So it's receded something like 15 miles. And that is hundreds of meters of depth of ice, retreating several tens of kilometers, which is a staggering amount of cold water that is entering Prince William Sound. And the recession just by Columbia Glacier over about a decade in the 90s was actually responsible for about 1% of sea level rise. That's how much water is moving into the ocean. So that's a long-term trend, but I have, of course, advertised heat waves. So let's zoom in here. This is the surface of the center of Prince William Sound over the last decade and a bit. And you can see the last few years, we are getting lots and lots of positive anomalies, so warmer than average. And that matches what other oceanographers were seeing in the Gulf as a whole. This is a paper from a paper by Emmanuel Di Lorenzo and Nate Mantua looking at this. The winter of 2014, a lot of people noticed that the Gulf of Alaska was quite a lot warmer than usual. My color scale has disappeared here, but the warmth in the central part of the Gulf was something like 2.5 degrees Celsius above average, which is a pretty big number. It's what the physicists called a 4 sigma warm event, so 4 standard deviations above the mean, a really, really big departure. And in looking into this, why did this happen? It appears that the mechanism was primarily atmospheric. It was the formation of what the meteorologists called the ridiculously resilient ridge. And that was a ridge of high pressure that formed in the Gulf. This right-hand panel is sea level pressure anomaly, so air pressure. And we had this wonderful high pressure time in the Gulf. For us, that means lots of sunny days and not a lot of wind. And that persisted for many, many weeks in the winter of 2014. And what that did was drastically reduce the amount of heat that got mixed out of the ocean. And so this is some model results from a paper by Nick Bond, who's the state climatologist down in Washington. And he was looking at, these are time series from 1981 till 2014. And if you look at the top panel here, the mean wind speed cubed in red in 2014 was really, really, really low. And then he looked at where heat was going in the ocean in these bottom panels. And the important one here is the red one, the net surface fluxes. So that's the amount of heat that usually gets mixed out of the ocean into the atmosphere every year. And in 2014, it was a lot lower than in prior years. And so the manifestation was that the mixed layer did not cool like it normally does. So this feature, which they started calling the blob because it's so blobby looking, was basically caused by not necessarily warming, but a lack of cooling, which it's all wrapped up within changes attributable to basically the amount of carbon dioxide we're pumping into the atmosphere. So here's another picture of, on the left, the blob temperature anomaly. And it happened again last year as well. We're obviously still working on what happened with that. But it appears that it was, again, a similar genesis. It was a lot of high pressure in the winter, and the heat from the prior summer just remained in the ocean over the entire winter and left a lot of residual heat in the ocean. And that's what we saw in Prince William Sound as well, if we come back to this. Here is 2014, the blob years. It was warm in Prince William Sound into 2016, 2017, perhaps on a trend towards cooling. But last year, it switched to very warm again, and even warmer than the blob years were, which is really something. So let's, oh, right, getting ahead of myself. I mentioned the profiler that we have. This is a picture of it. It's basically a robot float. It has a winch on it in the middle here and a whole bunch of buoyancy on it. And we toss it out in the middle of Prince William Sound and let it sit out there for about a month at a time. And how it works is it'll wake up and start floating towards the surface by paying out line in that winch, all the while measuring all kinds of oceanographic things, temperature, salinity, phytoplankton. It connects into the cell site, sends out a little bit of data, and then pulls itself back down to depth and goes to sleep for about 12 hours, and then does it again. So this profiler is sitting out there. It's out there right now, doing 2 profiles a day of all kinds of oceanographic things, but I'm going to focus on temperature today. And so here are the anomalies in central Prince William Sound from that profiler, which we started deploying in 2014. So each panel is a successive year. The gaps are from sometimes the batteries run out and we don't get to it in time. We've had some breakdowns and stuff. But this shows very nicely the tremendous amount of extra heat that we've been seeing in Prince William Sound. Pretty much every year of this record, we see positive anomalies near the surface. Very, very warm. Another kind of neat feature you might notice is all this blue at the bottom. So that is water that is cooler than average. And I'm still working on this, but I think what this means is that the surface layer of the sound is much stronger and narrower than it has been historically. So the surface layer used to be deeper than it has been in the last few years. And that has implications for biological productivity, because the amount of nutrients that are available to phytoplankton in that surface layer are kind of what controls the annual amount of production that happens in the sound. And we can look at that a little more closely. I've put together a time series of chlorophyll. Chlorophyll is the pigment used for photosynthesis, and it tells us sort of a kludgy way of estimating how much plant biomass there is at the surface. And these are taken from 2 different NASA satellite missions that started in 1998 and are still ongoing. And so these are each year's time series of basically primary productivity in the Central Sound from 1998 to present. And we can see that that spring bloom that I'd mentioned happens most years, though the size of it does vary. And then we do also sometimes see that autumn bloom. And so if we dive into that time series and look at just how much chlorophyll we're seeing over the year, that's this top panel here, we see a pretty clear trend towards less chlorophyll over time since 1998 to the present, especially the last few years, which have been marine heat wave years. If we look at the timing of the bloom, there doesn't really seem to be much of a change. I also have a little note here to remind myself, we only just recently started looking at the kinds of phytoplankton in Prince William Sound, actually looking to check up on paralytic shellfish poisoning in the Sound. But during the blob years in Lower Cook Inlet around Homer, there were reports of very different phytoplankton assemblages, and some of them actually being red tide or toxin-producing phytoplankton. In the zooplankton in the Sound, we're seeing some pretty big shifts in what kind of zooplankton we're seeing. These are anomaly plots of the amount of different kinds of zooplankton. The top panel is just all zooplankton together. The middle panel is what we call cool water species, the species where we usually see in the Northern Gulf. And then warm water species are species that are more common to Washington and Oregon. And what we saw in those warm years was a shift from cool water species that we normally see to warm water California and Oregon type species. And the reason that's important is I've got a picture here. This is a copepod, it's a crustacean of that cool water assemblage. And these are basically lipid-filled dirigibles. Inside his carapace here, you can see this little sac. That's oil, that's a wax ester. And that's fat that it puts on to complete its life history. So that is a little morsel of lipid for anything that consumes it. Whereas the southern species that we see are much smaller and they have much less lipid reserves. So they're probably much less quality food to things that are consuming them. We're also seeing this weird little invader down on the bottom here. This is a copepod called Corycius. And it is it's a predator, actually. It will just glom on to other plankton and basically chew on them till they die. And we never really saw those in the region until 2014 after the blob. And we're still puzzling out what that might mean for the ecosystem. So I'm going to kind of move up the food web of some of the changes that we saw in the Sound and the North Gulf region, because not everything was done entirely in Prince William Sound. I'm going to be borrowing lots of figures from my various collaborators. This is a time series of herring in Prince William Sound. Now, herring has really not been doing particularly well since the oil spill. It collapsed in the early 90s. But these are 2 estimates of the amount of herring from using sounders on ships and from looking at the amount of spawning that they do. You can see in the last few years, herring has been very, very low in Prince William Sound. Vanessa von Biela at NOAA and others have also been looking at the energy content of some forage fish. This is for sand lance. And looking over time, they're now seeing that 1-year-old fish basically had the same weight and energy density as a just born fish. So they're basically not growing. And that's perhaps a consequence of changes in the kind of plankton that they're seeing and how much lipid energy is available. There is a long running study at Middleton Island looking at diets in kittiwakes. They eat mostly forage fish. And again, around the blob years, they saw a large shift in what kittiwakes were eating. They went from eating largely capelin. Capelin tend to prefer cool water, to all kinds of other things. Nyctophids are lanternfish. They're deep water fish that spend most of the day way down deep, unavailable to them. And switching over a little bit to what herring that they can find. There's, of course, a very large myrrh rack, a myrrh die-off that happened in 2014. This is a picture from, it was, I think, ADN that David Irons took. They found several thousand dead myrrhs just by Whittier. And looking at their weights, it seemed like all the myrrhs that they were collecting were basically at starvation weight. And that wasn't just confined to Alaska. That was a huge die-off, basically Gulf of Alaska wide, and as well as down south. Something like upwards of a million myrrhs died in that event, starved. Here's a slide from Rob Surian looking at several indexes of seabird productivity and marine mammal productivity, and most of them are negative. Kittiwakes were doing poorly, sea lions were doing poorly, whales were quite rare, as were killer whales. And here's a poster I grabbed of Jan Straley's. Jan works out of Sitka, but does a lot of work in Prince William Sound. There's a lot going on here, but the important thing here is this 60% decline in whales in the region that's been observed in the last few years. Prince William Sound used to be kind of a hotspot for whales in the winter. There would be dozens to over 100 humpback whales in Prince William Sound, and now there seems to be generally less than 10. And the whale researchers really don't know where a lot of those whales have got to. That's some concern for sure. And of course, this has affected a lot of fisheries as well. The Prince William Sound pink salmon fishery was declared a federal fisheries disaster in 2016. Catches were way down. As well, cod has been doing particularly poorly. It appears that in the last few years, cod has had a complete recruitment failure. So there has basically just been no baby cod being produced to replenish the population. And this is ongoing. The return of warmth has not been good for cod, and the fishery is basically closed at this point. And I thought I'd just wrap up here at the end with some of the predictions for what's going to happen and kind of where we're at right now. This is a slide I took from a presentation that Manu Di Lorenzo did at the Ocean Sciences meeting this last February. He has a model for the North Pacific, and this was his prediction for sea surface temperature anomaly for this spring. So that's April, May, and June, kind of smooshed together. So really predicting a return to considerable warmth in the Gulf this year. And here is this is the NOAA SST, sea surface temperature anomaly plot from last Thursday, showing again lots of warm anomalies in the Gulf, and we can pop back and forth, pretty close to Manu's prediction. lots and lots of heat in the ocean. And just this morning, I had a quick look at the data from the profiler this year. So this is current as of last night. This is temperature anomaly in central Prince William Sound from April. It was the 20th when we put it out till about 1 a.m. this morning. And it looks like we're getting quite warm in the Sound as well, something like a +2 degree Celsius warm anomaly already here. And we'll be watching how things develop over the summer. So that's what I have for you today, and I'd be delighted to answer any questions you might have.
Great. Let me put my...
Get back. Oh, there we are.
Great, thanks, Rob. I have a question for you, and I think that last slide might have said it. Was how deep is the warm layer?
Something like 10 meters.
10 meters. Okay. And I've heard that might affect the bird's ability to forage. Have you heard anything about that? Like it's deeper or less deep, and somehow driving their food down deeper? Do you have anything about that?
I haven't. What we're seeing in the Sound is with that layer shallowing, there can actually be a thin little band of production that happens right at the edge of it, because it's near the deep water, which has lots of nutrients in it, but also near the surface where it can get sunlight. So the phytoplankton, the plants can grow, and then other things will eat that. But the problem is when that layer is thinner, there's just less nutrient available overall. So there's fewer plankton, so less there for birds to eat.
Great, excellent. Do we have any other questions? You can type something in for Rob. We've got another minute or two left here. And go ahead and type it. I think right now, thank you, Rob. That was a really informative, that sobering presentation. Well, now folks will have a 10-minute break. So stretch your legs, Java up. We'll be back in 10 minutes with our session on land management. So stay put, and we'll be right back with a very informative session on the land management and a couple other topics. Thanks, Rob.
Sure.